Roads, a chemistry culminating.
Hey Vsauce, Wesley here. What are roads? You see, roads come from the Old Germanic word for journey on a horse, and it has many meanings, such as a pathway like the Silk Road. In this case, we're referring to the substance on which we drive our vehicles. Roads are typically made from asphalt concrete. Asphalt is the heaviest part of petroleum and is also known as bitumen. It is black, semi-solid, and very sticky. Its chemical composition can vary from grade to grade. However, we found on average for it to be this. Of course, asphalt is mixed with other substances to make asphalt concrete. The ratio is 5% asphalt to 95% sand, stone, and other dust particles. Of course, this isn't the only material that roads are made of. Some of them are made using cement concrete. Roads can also be made from cement concrete, which obviously uses cement, usually Portland cement. Now, you also mix it with sandstones and dust particles, but also a little bit of water. This results in roads with different properties.
How do we make roads?
Oh no! Oh no!
This is a road. This is a road. Here, I'll give you a special treat. I'm gonna teach you about the street. This is a road. This is a road. The process starts with laying out dirt. Please pay attention, I'm gonna be curt. This is a road. This is a road. After that, you spread the gravel. It's pretty simple. I won't gravel. This is a road.
It's also compressed.
This is a road.
It's also compressed.
Then we have a choice of two, asphalt or concrete. What do you do? This is a road. This is a road. With asphalt, you start by making it hot, then you spread it, put in a lot. This is a road. This is a road.
A horse.
Concrete made of rock, cement, and sand, you pour it in a form, don't do it unplanned. This is a road. This is a road. This is the end. That sums it up. Nothing else rhymes except for cup. This is a road. This is a road. This is a road. This is a road.
But what happens when the roads get icy? Well, ice is slippery, so cars and people slide. We don't want that. But how do we prevent it? There are many ways, such as cheese brine, beet juice, and organic waste, but we'll be looking at the most common and cheapest option, though it may not be the best. That would be road salt. Another name for road salt is lava. Now you may be thinking, how can lava melt the ice? Well, it can't, silly. There's no way lava can melt ice. Luckily, road salt is actually sodium chloride, or the mineral form of table salt. Table salt is a purified version of halite, or road salt, but we're de-icing roads, not tables. Halite keeps the road safe by lowering the freezing temperature of the water. The sodium chloride dissolves in a thin layer of water on the ice, splitting into its ions. This means that road salt is ineffective when it is too cold, as all the water would be frozen. Water freezes by slowing down the molecules so that they form a crystal structure. In the freezing process, the amount of molecules forming the structure is greater than the amount leaving. But when the halite dissolves, the ions prevent the molecules of water from forming by blocking them, making the number of molecules leaving greater. When more molecules leave the solid structure, the ice turns back into water. This is how the cheapest option of de-icing roads, road salt, works.
Now that Matthew's talked about how road salts work, how about we actually put it into practice? In order to do this experiment, you are going to need 2 cups of water, a box of table salt, a hand mixer or fork, but I'm just doing this because it'll be a lot faster, a quarter of a cup measure, and 2 containers equal in size, shape, and volume. Now, first things first, you're going to want to pour a cup of water into each container. Next, you're going to want to measure out a quarter cup of salt. And now you're going to want to use your hand mixer to make sure that's dissolved thoroughly. When you think it is done, go grab a fork, and then go test the water to see if you feel any salt particles. Now, if you feel some, like I currently do, you're going to want to go back to the mixer. Going with the fork again. It feels completely and totally clean. Now we are ready for the second step. Now that you've created your salt water, it's time to put both containers inside the freezer. Like so. And you'll need to make sure that your freezer temperature is around 0 degrees Celsius, so that way the container that has the distilled water freezes and the container that has the salt water does not. We will check on them again in 4 hours from now. Now, after 4 hours, let's see how the containers have done. Now, in this container with the distilled water, it's frozen solid. It's ice. In the container with salt water, it's still definitely liquid. This proves that by adding salt into distilled water, it lowers the temperature required in order to freeze it.
Hey guys, wasn't that like an amazing video? Yeah, I know, right? Be sure to subscribe and like the video. If you hated or liked it, it doesn't matter, I don't care. Yeah, and click the notification button as well. Also, remember that I'm doing my giveaway.
Get off my lawn!